In approximately 1 billion years, the Earth will become too hot to sustain oceans on its surface, and all life here will be gone. That's why we're already searching for a new home. The explorer within us made it possible to conquer the most inhospitable corners of our planet. We navigated through dense undergrowth, creating paths where none existed before, discovering new biological species, and establishing safe habitats in the middle of jungle wilderness. In the early 20th century, adventurers, equipped only with rudimentary gear, explored the realm of eternal ice and silence, Antarctica. Survival in this frozen wasteland took superhuman creativity and adaptation. Today, our ambitions extend far beyond the most secluded parts of Earth. As we look into the night sky, we wonder, is there another place like home for us? For a long time, we've considered Mars as the next stop in humanity's cosmic history. That turned out to be nothing but a fantasy, a long-shot projection impossible to achieve. It seemed there would be no place else for us until one day we discovered Titan, an enigmatic celestial object so similar to Earth that it revived our hope in the search for a second home. What does it take to build a colony millions of miles away from Earth? Why is colonizing Mars a bad idea? There's terrain we can work on, oxygen we can breathe, drinking water, comfortable temperatures, and a shield against all kinds of radiation. All of these conditions are vital for life as we know it, but finding them elsewhere in the space is like winning the lottery. Take Mars, for example. Geological records show that the planet was once like Earth. Mars had lakes on its surface, a warm climate, and potentially life, but all that has long been gone. And today, the planet is nothing like what it used to be. Colonizing Mars makes no sense. It's a lifeless desert where the average temperature is a bone-chilling 80 degrees. It's a distant world where radiation is so strong that each step on the Martian soil brings you closer to an ultimate demise. But let's imagine we decided to establish a colony on Mars. What would it take? A crew of colonists boards a space rocket on Earth, and about 7 months later, they'll be the first humans to set foot on the red planet. The first task is to build a safe habitat, a sealed environment capable of preserving the right air pressure, oxygen levels, and temperature. The area has to be big enough for people to live in, have all the necessary equipment to stay alive, but also have room for inside projects like excavation or farming. Scientists are studying Mars for the safest location rich in minerals, where the first megastructures will soon be built. A chain of large domes forms the foundation of the future settlement. One problem is ensuring they shelter from intense cosmic radiation and dust storms, and humanity builds its first housing on an alien world. Buildings extend underground, connected to other domes through a system of tunnels. At this point, the colony is no longer threatened by external sources, but it still relies on water, oxygen, energy. Life in a colony is not easy. Biologists spend most of their days figuring out ways to enhance vegetation growth, which requires uninterrupted focus, since even slight fluctuations in temperature, pressure, gravity, or humidity could threaten the entire harvest. At some point, the colony will fully depend on it. Along with scientists, live outside the domes for the most part, searching for potential ice deposits. Nothing ever goes to waste. Water, minerals, sweat, and even urine are recycled. 3D printers are used to create spacecraft components and essential instruments, as shipments from Earth take too long and the colony might not have the time to wait. The system is fragile, with no room for error in sustaining life. Mars has a very thin atmosphere, about 100 times thinner than Earth's, meaning there's 99% less air or ice/air on Mars than on our planet, allowing more objects from space to reach the ground without burning up. Moreover, since the planet's core is frozen, there's no magnetic shield, leaving colonists exposed to cosmic and solar radiation. Elon Musk has proposed an intriguing solution: artificially generating an atmosphere on Mars by raising global temperatures through nuclear detonations over its poles. However, this plan won't work. While water vapor and carbon dioxide are essential greenhouse gases on Earth, Mars' atmosphere, though containing CO2, is only 1% as dense as Earth's, making it insufficient to trap heat effectively. A significant portion of the carbon dioxide on Mars is trapped in non-atmospheric reservoirs like polar ice and minerals, making it difficult to access. Even if we could somehow tap into these reservoirs, the available CO2 wouldn't be sufficient to meaningfully affect the planet's atmosphere. Atmospheric pressure on Earth at sea level is about 1 bar, equivalent to 1 kilos of air pushing down on every square centimeter. Currently, Mars has a very low atmospheric pressure of around 6 millibars, or about 15 grams of carbon dioxide per square centimeter. To sustain liquid water on the planet's surface, we would need to increase this pressure to roughly 2,500 grams per square centimeter, over 150 times more CO2 than Mars currently holds. It's akin to trying to inflate a balloon without enough air. Melting polar ice caps to release water vapor would fail as well, since the lack of heat-trapping gases in the atmosphere would cause the vapor to refreeze due to the cold temperatures. Moreover, detonating nuclear warheads to increase atmospheric pressure would introduce dangerous radiation, further compromising Mars's habitability, especially near the poles. While this idea is intriguing, it is more of a thought experiment than a feasible solution. The only real advantage Mars offers than Mars, unlike the International Space Station, which orbits a mere 250 miles above Earth and requires constant resupply, Titan already has an abundance of resources on its surface. Although it took the Cassini spacecraft nearly 7 years to reach Saturn, future technological advancements might reduce that journey time to about 2 years within the next 50 years. A group of settlers on Titan would face average temperatures of 300 degrees in a desolate landscape, but they would have a better chance at long-term survival than on Mars. One major advantage is Titan's atmosphere, which is about 50% thicker than Earth's. This thick atmosphere makes terraforming more feasible by enabling a greenhouse effect, which could gradually raise temperatures. While Titan is over 5 times farther from Earth than Mars, even a slight temperature increase of about 75 degrees could potentially turn liquid methane on Titan into gas, triggering a chain reaction that could transform the moon's environment. The methane rain cycle would stop, ice would begin melting, and the moon could eventually become covered with oceans. However, this is a long-term projection that would take an immense amount of time to unfold. Titan's atmospheric pressure is 50% higher than Earth's. In contrast, Mars's atmosphere is so thin that walking without a pressure suit would be akin to being exposed to open space, causing the body to swell, muscles to stiffen, lungs to rupture, and bodily fluids, including blood, to boil. Despite the hostile conditions on Titan's surface, it is rich in valuable resources. Titan is essentially a hydrocarbon factory, producing compounds like propylene, a key ingredient in plastics and resins on Earth. these materials could prove essential, the hazy atmosphere would make navigation challenging. Despite this, settlers may not need protective domes to begin establishing their habitats. Although Titan lacks its own magnetic field, it is shielded by Saturn's rotating magnetic field and spends 95% of its time under the planet's protection. As settlers explore Titan, it starts to seem less alien. However, instead of water, these bodies of liquid are filled with methane and ethane natural gases that, on Earth, are primarily composed of methane. There's so much methane on Titan that if oxygen were present, since Titan is 880 million miles away from the sun, solar energy generation isn't feasible. However, just as we use lakes and seas to generate hydropower, methane on Titan can be harnessed for power generation. Scientists believe there's enough methane on Titan to produce energy for thousands of years. Moreover, methane contributes to the formation, consisting mostly of nitrogen with about 5% methane and small amounts of carbon-rich compounds, reacts with sunlight and high-energy particles from Saturn's magnetic field. This interaction produces complex organics. Oxygen production experiments are underway in controlled. While populating Titan is no easy feat, it presents a more promising opportunity compared to Mars for such an ambitious endeavor. Although Titan isn't the only moon open for colonization, with Europa, Enceladus, and Ganymede also being potential candidates, exploring these options further could provide more insights into their suitability. Drop a comment below and give us a like if you want to hear more on this topic. Thanks for watching.